Hey everybody, this is our lesson on physical and chemical properties and changes. By the end of this lesson, you should be able to compare the physical and chemical properties of various types of matter, but if you have not already, pause the video and go and review mixtures before you start, because we're going to kind of talk about those a little bit throughout this lesson. So first, let's start with physical properties, and these are any characteristic of matter that can be observed but doesn't change the composition of the substance. So you can change what it looks like, but you're going to still have the same substance at the end that you started with. So this can be used to describe matter, and here are just some examples of physical properties. So your phases, boiling point, freezing point, those temperatures that are used to measure when a change occurs. Color, be careful with color though, because it can also fall as a chemical property. Shape, size, density, conductivity, malleability, viscosity, just to name a few of your examples. Some may describe the appearance of a substance or the behavior of a substance. So behavior would be like conductivity, malleability, ductility, viscosity. Appearance would be size, shape, color, those kind of things. And these can be used to separate your mixtures. So like distillation. Distillation is used or uses boiling point to separate substances. Filtration uses size to separate substances, just for examples. So here, Pikachu's pretty conductive. So now let's talk about physical changes. And these are changes in size, shape, or state of matter. Does not change the identity of the substance. So again, whatever you start with is what you end with. So all of your phase changes are physical changes because, for instance, ice we know is solid water. Well, then if you melt that, it becomes liquid water, but we didn't change the chemical composition of the substance. We just changed what the state was. So that's why a phase change is considered a physical change. Some other examples are like breaking, cutting, grinding. So if you take a piece of paper and you rip it up into smaller pieces, it's still paper. You've just changed the size. So that's what makes it a physical change. And again, can be used to separate your mixtures. And we just went over filtration and distillation, so you can look over those definitions. Now let's go into chemical properties and changes. So a chemical property is a characteristic of a substance that indicates how a substance reacts to form other substances. So here we are changing the composition. What you end with is not what you started with. And these are indicated by flammability is a huge one. So this is the likelihood that something will burn. Photosensitivity, which is exposure to light. Oxidation, which is exposure to oxygen or air. And for that one, you can think like rusting. So, iron will rust when it's exposed to oxygen over a length of time. So that would be oxidation. So this may be shown on the container as a danger or caution warning symbol, especially with flammability. Another one you could see is toxicity. Those kind of things are chemical properties. So you'll look for, these little symbols here on bottles. So now chemical changes are when a substance is changed into that new substance via a chemical reaction of whatever sort. So you could have one or more new substances produced depending on what type of reaction takes place. And the new substances will have different properties from the original because you have made something completely new. These are chemical changes that you can see are smell, sight, sound, color changes in some cases. Gas release is a big one. So if you see bubbling, that is considered a chemical change because you had gas production. If you feel a temperature change, that is also, so heat released or absorbed, that's also a very big chemical change. if it reacts with an acid or a base, if it reacts with water, anything that says reacts with would make a property, and then when it does that, it becomes the change. And then you will have some sort of energy change. So you will take energy in or lose energy during this process. So now that we've talked about those, let's just quickly go over the law of conservation of mass. And this just says that matter is neither created nor destroyed in a chemical change. It's always just changed into something else. There's no gain or loss of mass during a chemical change. Again, it's just transformed from one form to another. The mass of all of your substances present before the chemical change, so your reactants, should equal the mass of your substances after the chemical change, your products. Okay. So now that we've gone over that, you should be able to distinguish between physical and chemical properties and changes.